let's continue our study on volume. In this lesson, we'll be learning about volume and displacement. Specifically, how displacement helps us find the volume of irregular shapes. Oh my, there are so many irregular shapes, but there are just a few regular shapes. Think about it. Think about three-dimensional shapes that we've dealt with. Three-dimensional objects that can hold things inside. I'm thinking of a sphere, a cylinder, a cuboid, a cube, a pyramid, a cone. I'm starting to run out of shapes that I'm thinking about, you know? But there are tons of irregular shapes. Think of the irregular shapes that you see around you. Your pencil, a toy, yourself. That's pretty irregular. Or should I say abnormal? Okay, let's learn some stuff. The first thing we're going to talk about is finding the volume of a solid using water. That's something that we just mentioned, you know, like an object in your room, one thing that you really like, or that pet rock you've been holding on for years that you found in the forest. You know, that pet rock has volume too. Not feelings, but volume. Let's say that rock had a volume of, I don't know, 10 centimeters cubed. That means that if we could mold the rock into a cube, like we have this shape of the rock, and we turn it into a cube, maybe that rock kind of looks like this, you know, starting to look like a guitar. Maybe an avocado, especially because it's green. Anyways, that means that this rock or steak or cube or something, that we could turn it into a cube and make it 10 centimeters cubed. Well, you have volume too. What if we said that your volume was 30,000 cubic centimeters? 30,000 cubic centimeters. That means if we took your body and turned it into a cube, that means we could actually find the dimensions of that cube and kind of make you into a box. Hey, whoa. Sorry, I don't mean to fit you into a box right now. So let's just continue. How do we find these volumes to begin with? Like, how could we actually measure your body or measure a rock in such a way that we know how much stuff is inside of it? Maybe you could pause this video right now and think about what are some of those ways. Have a discussion with a parent who's close by to think about what these would be. Now, for students who have been in Singapore math before, you've studied this idea before, and you know a little bit of what we're going to talk about in this lesson. But I want to propose a few ideas. I want to propose that you could compare that object to a regular shape that's kind of similar to that. So, I don't know, I think about something that weighs about the same as me and has a similar shape but a little bit more boxy, you know? I guess like a light post? Or you take that rock and you try to find something that is a similar shape to it, but just a little bit more boxy that you can measure easier. Or maybe you thought about it, put the object in water. Then we could find out how much the water has been displaced and compare those two volumes to each other. But that key word displacement, or displace, well, that dis prefix comes from a Latin word meaning away. So we have away place, or basically move something from its place. Basically, displacement is just moving something up, down, left, right, diagonally. All right, so let's take a look at a few examples that deal with displacement. In this one, we have this rectangular tank, and the measurements are here listed in front of you. And this corresponds to your textbook, and that's on page 57. So we have some water, and then there's this stone inside here. It's a beautiful little stone that we collected on our hike. And when the stone was taken out, the height dropped of the cuboid, the rectangular tank, from 10 centimeters to 8 centimeters. So currently it's 10. We'll take the rock out, and it will reduce in height. So our goal is to find the volume of the stone. So first of all, notice that this pet rock has got like kind of an odd shape. And you know, I didn't draw it in 3 dimensions, but basically it could be kind of flat or curved in different parts and unique. Let's do two things here. Let's find the volume of the rectangular tank with the rock. And that's 35 times 35 times 10. Let's do a little partial mental math. 30 times 30 is 900. 5 times 30 is 150 twice. And then 5 times 5 is 25. So that, my friends, is 900 plus 300, which is 1225. Times 10 is 1225 with a 0 on the end. The volume with the rock is 12,250 centimeters cubed. Well, now let's find the volume without the rock. So that would still be 35 times 35, but now we'll do 8. And I think I'm done with the mental math. I'll just put this in my calculator. And that gives us 9,800 centimeters cubed. And then we basically just subtract these two. Hey, that's pretty simple. Pretty straightforward. That means we'll do 12,250 minus 9,800. And that gives us 2,450. 2,450 centimeters cubed. Now, some of you went through this and you're thinking, oh my gosh, I know of a shortcut, and all I have to do is find out that the difference in these two heights is just 2. So what we could do is we could take that difference 2 and multiply it by 35 and 35. And if we do that, we get 35 times 35, which is that 1225, times 2, which is 2450. So I'll just write that a little bit here. Here's the shortcut, is 35 times 35 times 2. Hey, that's the first example. That's just dealing with displacement. We have another one dealing with displacement, but slightly different. Let me just go through it. What we have here is we basically have the tank and then we remove the stone. But this example, what we'll do is place these cubes in the tank. All right, so we have a cuboid tank that's 50 by 40 by 40, and it's half filled with water. It's half filled with water. Oh my goodness. Doesn't really look like it's half filled. Let's pretend. That took me a lot to color that in, just telling you. Okay. All right, so 3 metal cubes. Hey, forget this. Let's deal with some Luigi's Mansion gems. I love those. Okay. They're 10 centimeters in their edges. So like just each little edge of these gems are 10 centimeters. And they're placed in the tank and the water rises. What's the new height of the water? I'm a little annoyed by this question because of this half-filled thing. So I want to do the original height real quick. So I just calculate what the original height is because it's half of 40. Like I said, my picture's off. So just take that 40 and divide it by 2, which is 20. Now I want to find out the volume of those cubes, those gems. So I'll do 10 times 10 times 10, which is, well, then times 3, because I have 3 of them. So that's equal to 3,000 centimeters cubed. Now, there are 2 ways that I could think of really quickly that we could finish this question. This is basically the last thing. Is one way, so stick with me, one way is to actually add this 3,000 to 50 times 40 times 40. So find the volume of the water inside here, add this volume. Now, once you have that final total, you need to divide by 50 and 40 to know how much the height has changed. So once again, you have those 3 dimensions, and there are 3 dimensions here. Get that sum and divide by the 50 and 40, 2 of the dimensions, to find the third one. Or you could do this thing here. We can take a little bit of what we learned in the intro video, that height equals volume divided by 2 dimensions, and set that up. We have a volume here, which is the 3000, the one that we just calculated for the cubes. We take that volume and divide by the 2 dimensions first, because then we just do less calculations. So once again, we would have multiplied out, added, and then divided by 50 and 40, but we're dividing first so that we just deal with smaller numbers. So to divide that, we'll do this in a different color here. There's 1 0 divided, here's another 0 divided, which gives us 30 over 20, which is 3 over 2, which is 1.5 centimeters. But what is that? Hey, that's the height that it changed. Therefore, the height of the new water level, the final height, is that original 20 centimeters plus 1.5, which is 21.5. All right, hey, if that didn't make sense to you, what you could do is you could actually go through that other way I told you. Take that volume of the original piece, sorry, not with the 40, I think I may have mentioned that earlier, with the 20 here, like just the water that's in there, so 50 times 40 times 20, and then add to 3000, take that final number and divide by 50, and then divide by 40, and you'll get that 21.5. Thanks so much for watching and learning with me. Until next time.